In this video, we're going to be looking at proving theorems about perpendicular lines. So for number one, we want to use the diagram to prove the perpendicular transversal theorem. So looking back on what that theorem was, it said if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So I see here, and we can look at this picture too and what I have written. I'm given two pieces of information. I'm given two parallel lines and two perpendicular lines. And I want to prove that these other two lines are perpendicular. And so looking at my diagram, I see that J is perpendicular to H, and I know that because of this right angle. So I know I'm given that J is perpendicular to H. And then I'm also given that H is parallel to K. And I know that because of these arrows right here, I see that means that they're parallel. And then to prove this theorem, I then need to come to the conclusion that J is therefore parallel to K. So now we can go ahead and start our proof. So I'm going to write my given information first. So J is parallel to H. H is parallel, or J is perpendicular to H. H is parallel to K. Both of these are given. And then I want to come to the conclusion that J is parallel or perpendicular to K. So I need to start with what I'm given and kind of think through what I can use with that given information. So first I'm given that J is perpendicular to H. So what's the definition of perpendicular? Well, the definition of perpendicular is that they intersect at a right angle. And so since J is perpendicular to H, I know that angle 2 is a right angle. And I'm also seeing that in this diagram here. So I can say angle 2 is a right angle. And that's just my definition of right angle. So that means to prove that J is perpendicular to K, I need to somehow get that either angle 5, 6, 7, or 8 is a right angle. And so that's going to end up needing to be right here. But we need to fill in some steps to prove that. And so next, I know that since angle 2 is a right angle, I can then say that the measure of angle 2 is equal to 90 degrees. So again, just using more definitions. So definition of right angle. And sorry about that. The previous reason should have been definition of perpendicular, because that was what we used to know that that was a right angle. So somehow, knowing that angle 2 is 90 degrees, I need to show that 5, 6, 7, or 8 is 90 degrees. So let's look at our other given information. Our other given information is that H is parallel to K. So these two lines are parallel. And then I have a transversal going through. So now I need to think through, what did we learn about parallel lines cut by transversal in the previous lessons? Well, we learned that corresponding angles are congruent. We learned about alternate interior angles, alternate exterior angles, and consecutive interior angles. So I need to think through which of these angles, 5, 6, 7, or 8, is congruent to angle 2. Because I want to show that one of these angles, 5, 6, 7, or 8, is 90 degrees. So there's a couple of different options you can do. You could do corresponding. I know that angle 2 and angle 6 are congruent since they're corresponding angles. I'm going to go ahead and use that. But another way that you can prove this is using angle 7 instead, because those are alternate exterior angles. Let's go ahead and use angle 2 and angle 6. So I know angle 2 is congruent to angle 6. And again, that's because they're corresponding angles. So that's going to be the corresponding angles theorem. and I want to show that measure of angle 6 is equal to 90 degrees, so I need to first change this to being measure. So that means that this is same thing as measure of angle 2 is equal to the measure of angle 6. And that's just definition of congruence. And now, since measure of angle 2 is equal to 90, measure of angle 2 is also equal to measure of angle 6, by the transitive property, I can therefore say that measure of angle 6 is equal to 90 degrees. And now, since I measure angle 6 90 degrees, I know that angle 6 is a right angle. And that's just definition of right angle. And therefore, J is parallel to K. And that is definition of perpendicular. So for number 2, this next proof is going to be a little bit shorter. Here I'm given that ABC is congruent to angle CBE and DE is perpendicular to AF. I want to prove that CB is parallel to DE. So I'm going to go ahead and write all my given information on one line. So I have that angle ABC is congruent to angle CBE. DE is perpendicular to AF. And then I want to prove that CB is parallel to DE. So I want to look at my first given information. I'm given that these two angles are congruent. So I see that this angle ABC is congruent to angle CBE. So now what does that given information tell us? Well, if we go back to our first theorem, the linear pair perpendicular theorem, that kind of looks like our picture here. And that said that if two lines intersect forming a linear pair of congruent angles, which we have, then the lines that make up those angles are perpendicular. So here I see that these two angles are a linear pair, they're congruent, so therefore that means that CB is perpendicular to AF. And again, that was by the linear pair perpendicular theorem. Now I conclude that therefore CB is parallel to DE. Now why can I say that? Well, I found out that these two lines are perpendicular. And so I see that CB is perpendicular to AF. DE is also perpendicular to AF. So since they're perpendicular, have two lines perpendicular to the same line, they're parallel. Well, what theorem tells us that? That's going to be the lines perpendicular to a transversal theorem. And again, that one says if two lines are perpendicular to the same line, then they're parallel to each other. So my last reason is lines perpendicular to a transversal theorem.